All right, I've got the first picture up here.
Mhm.
Which questions do you want to work on? So what I'm going to do, I'm just gonna copy these down. These aren't too bad. So number 9, we've got, and this is just the way that they're showing sets here. X such that X is between -1 and 4. Okay, so they want you to graph on a number line. So here's our number. I'm gonna actually do it more accurate. There's -1, there's 0, there's 1, 2, 3, and 4 right there. And
Mhm.
our number line here. Now these symbols mean that you're gonna have an open circle. So at -1 and 4, you've got an open circle, and this just says to highlight everything in between them.
Okay. Number 11, we got.
So are you doing odds or evens or all?
I'm doing all of them
Okay.
for.
Why don't I do the evens, or we work through some of the evens just because you'll have the odds available to you in the back. At least we can always come back. So we have x, and then this vertical line means such that x is greater than or equal to -3. So on a number line, and I'll just put -3 right in the middle there. When you see this symbol with the line underneath, the greater than or equal to, less than or equal to, it's a filled in bubble.
Yeah.
That's a filled in bubble. Greater than means to the right. Okay. Now, I see that it says to use interval notation. I didn't catch that on the first one. So on number 9, um, there's parentheses that go along with less than or greater than, and then brackets that go along with less than or equal to and greater than or equal to.
Yeah.
So for the first one, it's parentheses -1 to 4. For the one on the right, I'm sorry, for the number 10, you have to remember that -infinity is over on the left and positive infinity is over to the right, because you
Yeah.
have to have two things in there. So it's going to be bracket -3, comma, infinity, parentheses. So infinities always go with the parentheses.
Okay.
So these always go with parentheses.
Makes sense. I'll try number 11. Let's see. Subset of x. X is less than 0. Okay. So write out this number line. 0. And x is less than 0, so it'll be a hollow circle,
Yep, and then it's
and it'll go off to the left.
that's right. So there's negative infinity over here to the left. So your two numbers here, because 0 is not included, it gets a parentheses. Negative infinity always gets a parentheses. So this is your interval
Okay.
notation.
So 0 doesn't get a bracket.
It does not, because it's not filled in. So that what I'm trying to show you up here in the top right is the ones that go together. So
Oh,
the greater than or equal to, less than or equal to, the filled in bubble, the brackets, those all go together. Less than, greater than, open circle, parentheses, infinities, they all go together. So there's kind of a grouping there.
all right.
All right.
Go to
So
number 12.
12 here. This one is written incorrectly in your textbook. They're just doing that to kind of, they're doing it to,
Cheating a little
I
bit.
guess, to give it to you in an unusual way, but it's always the smallest number, smallest to largest.
Yeah.
So here clearly three is less than 8, so it should be, and you have to rewrite this, it should be x such that 3 less than x less than 8. Now the reason these brackets go the way that, in the direction that they do, is they have to see how this pointy side, I don't know, that's pointing towards the 3. I don't know, I guess they call it like a mouth, but it's still pointing towards the 3.
Okay.
So that's why it goes in this direction. It has to be written from smallest to largest to be able to make any sort of sense of these questions here. So to graph it on a number line, because it's a less than and a less than, You're going to
Okay,
put
so they both go
open.
left?
No, it's between.
Oh, between? Okay.
Yes, yes. Whenever you see X and you have a symbol here and symbol here, this is between this
Okay.
and this X between. Sometimes you'll hear me say inside case or the inside example.
All right. And then for in between, it'll just be 3 comma 8
Yeah, so it's going to be 3 comma 8 with parentheses
parentheses.
because neither
Oh, good. Because neither what?
because neither one are included.
Okay, cool.
So we could even add some words in here like these include and these exclude.
Perfect. Including. All right. Number 13, we got subset of x. 1 is less than or equal to x. Wait, no, yeah, less than or equal to x, and x is less than 2.
So here on the number line, the 1 is included. So
Oh,
it's
okay.
a filled in one because of that symbol right there. But 2 is not. It's excluded. It's just because of that symbol there. And then it's everything in between them.
Okay. And then the 1 is a filled in, and the 2 is a hollow, right?
That's right. That's right.
Is it filled in?
Are you seeing my screen? Just
Yeah, I am.
okay. And we are screen recording this, so you'll see that. You'll have that at the end as well.
Okay, perfect. And how come the 1 has a bracket again? Is it because of the filled in bubble?
Yeah, because it's included. Because it's included, it's a filled in bubble. The like if you have a filled in bubble, you're going to use a bracket. If you have a filled in bubble, it's less than or equal to or greater than or equal to. These things all go together. So the only notes that are really besides examples are what I've got here in the top right. That's the thing you take away from class. I mean that's your lesson, and then you go and do some problems. All right, 14. If we need it, do you need 14?
Yeah.
Okay, so 14. X such that -5 less than x less than or equal to -4. So you got those two numbers on a number line.
Mm-hmm.
-5, -4. -4 is filled in because of the less than or equal to. -5 is not, and then it's everything in between them.
Mm-hmm. Filled in, and it will be all right. Bracket. Alrighty. On the number 15, using the variable x, write each interval using set builder notation.
This is the backwards question. This is the backwards one. I just gave you, or we just did ones forwards where they give you the set builder, and now you're going backwards. So all of these previous problems were set builder to interval, and that's the forwards. The backwards is I give you the interval, now you give me the set builder. So one way to do this is to just look up at your steps and be like, oh, how did I go from here to here? And then how did I go from here to here? If you need to, or you can just make a big leap back to the set builder. So this one is -4 to 3. So if
Mm-hmm.
you were to make a number line, there's -4.
Yeah.
Okay, and there's 3. And you say, okay, well, there's an open circle, and it's everything in between. So that's
Okay. So
-4, x, and 3. And because it's an open circle in both places, I get that
perfect.
symbol. And then you just have to add in that set builder part.
Subset. Perfect. All right. On the number 16, Maybe I think I can do this one. All right,
All right,
so,
go ahead and give it a try, and I'll write the answer when you're done.
so finished it.
All right, so the way it looks is it's going to be x such that 2 is less than or equal to x less than 7, like this. This is your final answer there.
So I got that correct. Let's get number 17 now.
Okay. This one is slightly different, but give it a try.
I think I'm finished with this one.
Okay, so here is the answer to 17. It is x such that x is less than or equal to -1.
Perfect. I got that correct.
Okay.
Note 18.
18.
Read infinity. All right. I finished number 18.
Okay, so this is x such that x is greater than 3.
Perfect. Let's try number 19. These are in between. Bracket means filled in. So this one will be x such that -2. I finished.
19.
Mm-hmm. Got x
Okay, so
subset -2 less than or equal to x less than 6.
yeah, the book, I guess they don't do a great job of, I guess, making it look like Princess. Maybe it looks better on your side. I guess maybe it's okay. All right, go ahead and give the next couple a try.
Right, now we move on to number 25.
25. Okay. All right. All right. So 25 says to determine the domain and range of each relation. So the reason it's a relation is that you're given a set of ordered pairs. You don't know whether it's a function. What you're looking for to determine whether something is a function is you're looking for duplicates in X.
Yeah.
So what I mean is there's a 5, a 3, a 4, and a 7. Do you agree?
Yeah.
Those are your X values. Are there any duplicates?
There are no duplicates.
So if there's no duplicates, then it is a function.
Oh, it is.
Yep.
Okay.
If there are duplicates, there's two possibilities. I mean, one is that it is a function, and the other is that it is not a function. All right. So that's how you decide whether it's a function when you have no duplicates, which is the case in 25. The way you determine the domain is the X values. So you're going to put the X values in ascending order is usually preferred. So that means increasing order.
Okay.
So in this problem, your domain is like you might write it like this 5, 3, 4, 7, but your instructor might want you to put it in ascending order like this.
All right.
Your range are the y values in ascending order. Okay. They don't have to like line up. You don't have to put like 1 in the same position as 5. You just have to put them in ascending order. So I see like 1, 2, 9, and 6. So you might write instead 1, 2, 6, 9.
Perfect. So if it isn't a function, we don't do the domain or range, right?
No, that is not the all. So this is sort of a side note here, I guess, is that all relations have a domain and range.
Okay. Perfect.
So we definitely need to, like, because this is not the test. I mean, this is not the quiz question you're going to get. The quiz question is going to be one where you have duplicates in the x. You like if you look at 27, there are no duplicates in the x, but there are duplicates in the y. That doesn't matter. You're looking for duplicates in the x. So 29 is a good one for us to do at some point.
All right.
But if you need to do 26, we can do 26 as well.
Let's go through 26 first.
Yeah. So the first thing that you do, very first question you ask yourself is, are there duplicates
There are no duplicates.
in the x? And there's not. So that means it is a function. No, so it is a function. Okay. The domain is the x values. So 8, 5, 9, 3. The range 0, 4, 3, 8. Didn't put them in order, but that doesn't matter.
All right.
For 27, there's a small little wrinkle to this problem. And the wrinkle is that when you write the domain or range, which I didn't write earlier, the domain or range, you only write duplicate numbers once.
Oh.
So for example, the range in 27, do you see how it's 6, 6? You just put 6.
Oh. All right, so I'll do that. What happens if there are duplicates in the y?
Nothing.
I mean, like with so when we do eventually get like duplicates in the x, what do we end up doing
Well,
to the domain?
we'll get there we'll get there in 29. But you only write them once, whether it's the domain or range. You only write the duplicates once.
All right, so that stays the same. That's good.
What is the domain for 27?
37, 1, 2, and 3.
You have to put a comma between the numbers. These curly braces.
Yep.
So, oh, and we didn't say it, but this is a function. So maybe 26 is unclear. It is a function. Yes, like it is a function, but the way you get there is you ask about the duplicates. This is a function. Function, yes. So try a 28 on your own, and let me know when you're done. Good.
So 25 through 27 are all functions, right?
Yes.
Perfect. All right, so for range, I got 5, and domain is -30, comma, -20, comma, -10, and it is a function. Can you hear me? Because I can't hear you for some reason.
This one has duplicates in X. I apologize, I was muted. 29 has duplicates in X, but that doesn't, we don't know. It either is a function or it's not. Okay, and what we're looking for, and it's now a new question. It's, does X go to the same value? So that's what we're looking for it's a function, or does it go to a different value?
It's a different value. The
Yeah, so
duplicates
so
here.
one time 3 goes to -5, but another time 3 goes to 7. These are different.
Yep.
So that means it's not a function. Not a function, but it does have a domain and a range. Not a function. The domain and range are done exactly the same way. Is that okay?
Yes, it is. All right, let's go on to number 30. All right, so there's duplicates in the X, and they go to different values, so it's not a function.
Agreed?
And domain would be 0, comma 1.
The domain is 0, comma 1. Agreed. What is the range?
Range in this case will be -4, comma 3, comma 5. All right. Now I'll go to number 31.
So,
This next,
so 31 through 34 are exactly the same as the previous one. You're looking for the same things. Are there duplicates in X? That's the key question you're asking for. They might say this differently in class, but it's a much simpler question. Are there duplicates in X? You don't care about Y.
there are
Are
no
there?
duplicates in both. There's duplicates in number 32 for
That's
X,
right.
but there's no duplicates for X in number 31. So it's function number 31, and it's not a function for number 32 because the X's go to different
Well,
values.
yes, exactly. There's that next little piece, because sometimes what they do is they'll give you a question where it looks like they give you duplicates, but then it goes to the same number each time.
Oh,
If that's not clear, I can give you an example of it.
it's clear. It's fine.
Okay. So like you said, 31, 33, and 34 are functions. 32 is not.
All right. Actually, could you give me an example of the what you said earlier about the X's being different, to being the same but going to different numbers, like trying to trick you?
Yeah, so this is the classic test question. It's an example of a test question. So I would give you, it would be very they play games with the numbers. So it would be like 0, comma 1, 1, comma 0. minus 1 comma 0, 0 comma 1, and then negative 1, sorry, 1 comma, sorry, let me actually use the, let me erase a few things here because this did not come out right. Come on. 0, 1. So something like this. This is your classic test question. So a lot of the same numbers, it looks like, but 1 or 0, 0 goes to 1 in this first ordered pair and the last. So that's
Yeah.
okay. This is a function. It is a function. Because, and I guess maybe I'll highlight them. Maybe that's helpful here. These are exactly the same.
That's, I understand. Thank you.
Okay,
That's
great.
perfectly clear. Let's go to number 35 now.
All right, 35, 36, 37. These three problems, this is, if you heard it in class, 35 through 37, you're looking for you're trying the vertical line test. You probably heard that in class.
Yeah.
Now, everything we just did is the vertical line test, but because it's a graph, you can actually draw a vertical line. Now, one of the really cool things about the fact that we're doing this electronically. This is one of those things that's like, it's like I can't do on pencil and paper because I got to redraw it. But watch this here. We're going to paste this in, and we're going to draw a vertical line, a vertical line, and a vertical line. How many times do they intersect?
0.
Once.
I mean, just once. My bad.
Once.
I mean, like,
and twice.
so 37 doesn't pass, and 35 and 36 do.
Yeah. Now, there's a little wrinkle to this one. Some students will say, well, let me actually, I'm gonna just recopy the last one here because there's kind of a little wrinkle to it, I guess. You could sit here and tell me, well, if I draw this line, it goes through 0 times, and that's true. The problem is you're bounded by, you can only choose a line in this region.
Yeah.
You can't go outside the region, so it does hit it twice. So this is wrong. This is correct.
That makes sense. And so for 35 through 37, it's just like saying whether or not it passes, right?
Yeah,
Yes,
so
no.
I didn't actually, I did the what you do, but I didn't really give you the answer. So yes, yes, no.
No.
And these are like true false in your test. You got to be very committed to your answer. You cannot waver. You have to be very confident in your decision.
That's fair. And we go through 38 to 39, and those both pass.
Yeah,
Yes.
30 and 39, same thing. 40, same thing, although it looks cut off.
The last one is going to be 53 through 59 odd.
So no to 41, no to 42, no to 43. Excuse me.
Yeah, that's a no.
Really?
So, yeah,
Okay, so we should just quickly talk about them. Like 41 is not a function. Do you agree with that?
yes, because it doesn't pass the vertical line test.
Okay. 46 is also this sort of classic exam question. So let me actually copy it over because this is classic. So do you see how 2 goes to both 15 and 19?
Yeah.
That's a problem. That's bad. Because 2 goes to 15, but then 2 also goes to 19. See how there's these are different?
Yeah.
That's bad. You're looking for, there are no duplicates in the X here. So it sort of violates what I said earlier, like where you look for the duplicates. But if you were to write these out as ordered pairs, you would see the duplicates in them.
Oh, okay.
Because 2 goes to 15 and 2 goes to 19. Well, that's not possible. So the other so the other sort of situation is a number going to two different numbers.
Perfect. That makes sense. Let's move on to number 53. So this is find f of x at the indicated value of x.
All right, well, this is asking you to put the value of x into the function. So you're literally just replacing x with that number. So 53, I'm going to start it differently. It says f of x equals 3x minus 4. They're saying put in -2. So what you're doing here is you're evaluating for x equals -2. In other words, you're putting that value of x into the function. Now, you'll notice here that I always do it in parentheses. This number right here is put in parentheses. It's really helpful to do that.
I always do that too.
That's great because it's just very very clear what you're doing, and then you're just simplifying. These are prerequisite math skills that you're getting.
So f of -2 equals -10. Now we go on to 55. And we got f of x equals 2x squared minus x plus 3, and x equals 1. So we'll get 2 parentheses 1 squared minus 1 plus 3. 1 squared is 1. 1 times 2 is 2. 2 minus 1 plus 3.
I guess I didn't hear which one you're doing next, so
Number 55.
Okay. I see. It's to the right there.
And it should be f of 1 equals 4 by the end of it.
So you're substituting in x equals 1.
Yep.
2 minus 1 plus 3. So that reduces to 4, and you're just simplifying. Great.
Last couple.
You have to do 57?
Yes, 57 and 59.
All right, so give 57 a try, and I'll give you the answer if you need it.
Thank you. X equals 4. So for 57, I ended up getting f of 4 equals -10. But for 59, is that no solution?
Let me work through it one at a time here. So 57, I'm going to give you the answer here shortly. It is -10, so I'm going to agree with you on that. And then you said for 59, you got no solution. So let's take a look at that one. No. This one is a function where there is nothing, there's no x. So 59 says f of x equals 5. Well, if you put 9 in for x, nothing changes on the right-hand side.
So it's just the answer, f of 9 equals 5, and that's it.
Yes, nothing changes.
That should be all the homework that I was assigned. Are there any problems that stuck out to you that you think that we should go over just in case?
Well, I think that where they're leading you to, and I'll give you an example of this. Um, let's say x is less than 3 and x is greater than or equal to 7. How would you show that on a number line?
Uh, in that case, I would. Um, hmm,
I mean, I'll help
I would
out here, but that's and this is not something you were asked, but let's just say that's 3 and that's 7. This one is an open circle. Less than means to the left, and
agreed.
filled in circle to the right. So here's negative infinity, here's positive infinity. In interval notation, you're going from negative infinity to 3, and you're going bracket 7 comma infinity, and then this means or.
Oh, yeah.
So that's something else to keep in mind. So that's kind of like that's another problem. So we could also go backwards. Like I could tell you, oh, what if something goes from negative infinity to -5 bracket union -2 to positive infinity? Can you graph that? Graph on a number line. Go ahead and give that a try, please.
All right, so they're both filled in uh, circles, and at -5 and at -2. -2 goes up to the right, fill in the arrow for that. And for -5, fill in the arrow and it goes left.
So it looks something like this, right?
Yep.
Great. Okay, so like you said, you're going to be another graph that they didn't give you for determining whether something is a function or not. The one graph that they didn't give you, actually, there's a couple they didn't give you. So here's one that they didn't give you. This is a classic one. This is not a function. Okay, and then the other one that they didn't give you is, let's say that this point is here and this one is here, but not filled in. This is a function. And the
Wait, that
reason it
does?
is because this line, it does hit there, but it does not there.
How though?
It's an open circle. So an open circle means it excludes that place.
That's cool. That's kind of cool.
Yeah, I mean, we could spend more time on it, but these are just things to remember. Another graph you might see is where you actually do have you have a dot here, and these are just points, one there, and one there, and one there, and one there. This is not a function because the line, it hits and it hits, so that's twice. So
Yeah.
that's no good there. So that's another little thing that that you might see. It also looks, the end of this is like a review of functions, and those functions you gotta there's about 8 of them. There's x squared, there's square root of x cubed, there's the cube root of x, there's the absolute value of x, and 1, 2, 3, 4, 5, 6. So I'm missing some. There might be a constant function, but these are all ones that you have to remember what to do when you're given a problem. So like if I made up a really complicated function like the absolute value of x minus the square root of x over the cube root of x plus the x squared, and I told you I'm going to put a 2 here, 2 times that, and I told you that x equals 1, could you figure out f of 1? Could you evaluate for x equals 1? Now most of these are 1, but this is kind of like, do you know all of your functions here?
I think that was everything that I wanted to go over today.
Are you sure?
Yeah.
All
You did a great job explaining it.
all right. Well, I'm happy to hear that.